Hello friends, today we will see Bode plot. Bode plot. What is Bode plot? So, Bode plot is tool to represent AC response, or you can say frequency response of system. It means how magnitude or gain varies with frequency, say omega, and how phase varies with omega, magnitude and phase. So for example, say we have system, say we have some system. Okay, system, its transfer function is hs, output here, input. Okay, so now uh, what Bode plot will do, it will tell how this system is going to respond if input frequency or frequency of signal is changing. For example, say you are giving some signal. Okay, you are giving some signal. Okay, so I will draw it. Suppose you are giving some input signal, say input signal. Okay, and you are getting some, say, output signal, say like this. So here, say this difference is, say, pi by 2, and say this amplitude is, say, A, and this is Vi, and this is Vo, and this amplitude is, say, 2A. Okay, and this is, say, time. So I am just giving you example to make understand. So now this is output, this is input. So gain Vo by Vi is 2, and phase difference is pi by 2. Okay, so this is for, say, frequency omega equals to, say, some frequency omega 1. Now for all frequency, if we want to represent, we need frequency response, and we use Bode plot. For example, say our x-axis is omega, and how our magnitude, and this one gain or magnitude, and this is phase. So how phase are changing with frequency actually. So this is the purpose of Bode plot. Okay, we can represent our system, say hs is our system. So this transfer function or response for system can be represented by magnitude and phase response. So this is phase and this is magnitude. Okay, now so this is about basic concept of Bode plot. Now in our system, this transfer function, it consists of say poles and zeros, say s by omega, say this is z1, s plus 1 by omega, say z2, and so on, and 1 minus s by omega p1, 1 by 1 plus s by omega p2. Now in this transfer function, we have left hand pole, we have right hand pole, we have left hand 0, right hand 0. So this is our right hand plane 0, this is left hand plane 0, this is right hand plane pole, this is left hand plane pole. Now if we have different types of poles and zero in our system, it is going to impact Bode plot, its magnitude and phase in different ways. Now let's see one by one how left hand pole or right hand pole is going to impact our Bode plot. We will also see how right hand plane 0 or left hand plane 0 is going to impact our Bode plot. So first we will see effect of, or we will see how left hand plane 0 is going to give this frequency response in Bode plot. So first we will see left hand plane pole. Say we consider transfer function equals to 1 plus 1 plus s by omega p. Okay, so this is our left hand plane pole. Okay, now in this case we find out magnitude is given by 1 by 1 plus omega square omega p square root. Okay, and this phase for HS is given by tangent inverse imaginary part upon real part. Okay, now this thing is in denominator here, this is in denominator. So what we will do, S basically equals to j omega. So what we will do, we will take multiply this with 1 minus j omega by omega p, 1 plus j omega, 1 minus j omega by omega p, and this is basically j omega. So it will come like 1 minus j omega upon omega p. This will be 1 minus plus j omega minus, so this will be j omega by omega p square. So this is something like that, this a square minus b square equals to a minus b, a plus b. Okay, so it will be a square minus b square, and this will be equals to 1 minus j omega upon omega p and 1 plus omega upon omega p square. Now in this case this is imaginary part divided by this term, and this is real part. So this will be tan inverse minus omega upon omega p divided by 1 plus omega upon omega p square divided by 1 plus omega upon omega p square. So this will cancel, so this will equals to minus tan inverse omega upon omega p. Okay, this will be our phase. Okay, now how phase plot for left hand pole look like? So this will be you can say minus 20 dB per decade, this is magnitude, and say from okay, so say this is omega p pole. Okay, from here it is going minus 20 dB per decade, and how this phase will be go down. So this is 0.1 omega p, and this frequency is 10 omega p. Okay, so this is 0, then this is minus 90 degree, and at omega p it is minus 45 degree, and this axis is omega, and this is phase.